Hello, everyone, and welcome back. Your girl, Audrey Codner-Gibson from ACG Math Tutoring. And yes, I'm here to help. Let's get started. Okay, everyone, and welcome back to another episode of Dealing with Algebra with me, your lovely girl, Audrey Codner-Gibson from ACG Math Tutoring. So let me share my screen with you. And as you notice, we're looking at the slope of the line. I love doing slope. And a lot of people will say, meh. Okay. So, but anyway, slope of a line, we're looking at the Common Core standards of AREI point 3 and AREI point 10. So before we touch on that, let's look at our exit ticket that we did last time when we were finding the X and Y intercepts to help us graph our line. So our equation was negative 2x plus 5y equals 10. So remember, when we're trying to find the X-intercept, we had to make the Y value equal to 0. So if I have my original equation, my negative 2x plus 5, instead of a y, I'm putting in a 0. And we all know that anything times 0 is 0. But in this case, we do not have to bring down the plus 0 because we have that negative 2x that's already on that side. And the 0 will just be a placeholder. So we'll have it equals 10. So now I'm going to divide both sides by negative 2. So that means we have our x is equal to negative 5. So this is telling me that my x-intercept in this case is going to be negative 5, 0. So we start at the origin. We're going to go to the left 5, and then we're going to place our point. So now we need to find the y-intercept. And now the y-intercept, that's when my x value has to equal 0. So wherever I see an x, I'm going to put a 0 in its place. So anything times 0 again is 0. So we don't need the 0 because it's a placeholder in this case because we still have that 5y. And I'm going to bring down my equals 10. So divide both sides by 5. And then we have y is equal to 2. So that means my y-intercept is 0, 2. So I'm starting at the origin at 0, and I'm going up 2. And then as best I can, let's see how wavy gravy this line's going to be. All right, not too shabby. It's not the best in the world, but we get the idea. All right. So if you said your x-intercept was negative 5, 0, and your y-intercept was 0, 2, thumbs up, high five, bump it. You got this, boo. All right. So what we're going to do today, you should be asking yourself, I can find the slope of the line algebraically and graphically. So we're going to look at our exit ticket. We're going to go through those guided notes. We're going to go through that practice so we can finish up with our exit ticket for this lesson. So slope of the line. Every time I do the lesson of slope when I was in the classroom, especially when I was in Anne Arundel County in Maryland, just in case we have people that are not from Maryland, I would play this video that I saw off of YouTube. So it's probably like the sound quality is probably horrible compared to today's standards. I'm so sorry, Prumpy. But it was just such an easy song to remember. It's called the Slope Song. And as soon as I can find it, I will probably tag it on the end of it. Or if anything, I'll see if I can find it and kind of like blurp it in there somewhere, maybe kind of close to the closure. But what is slope? Slope of a line, slope of a hill, slope of anything, a road. The slope is referring to how steep that line is. So have you ever like walked and all of a sudden you had to go up a hill? I used to work at a school that was on top of the hill, and just to see the kids trudging up the hill, and once they get into the classroom, they're like pouring with sweat, and it's in the winter. And they were just like, the hill, lady, the hill killed me, you know. I'm like, well, you be in shape, but make sure you get to class on time. Okay. So it's how steep that line is. So our lines could be like parallel, ignore the ash. It could be up, it could be completely up, it could be basically straight up and down. So it depends on how steep that line is. So the ratio of the rise is basically the change of the y direction. So if I'm saying I want to do the rise over the run, okay? So your rise deals with, are you moving up or are you moving down? The run is the direction of the x values. Are you moving to the left or are you moving to the right, okay? So you need at least 2 points in the line to find the possible slope. So we can use this formula, y2 minus 1 over x sub 2 minus x sub 1, or y1 minus y2, or x1 minus x2. The key part is that your 2 and your 1s have to line up, and your y's have to stay on the top. Your y's is going to be your rise, and your denominator is going to be your run. So it's the change or the pattern of your y's over the change or the pattern of your x's. These little triangles that I'm drawing, they're called deltas. That's a Greek letter meaning change, okay? See, learn a little something extra, all right? So now let's take a look at the helpful hints. So we're looking at 4 different types of slopes, okay? So we're looking at a positive slope, a negative slope, a horizontal slope, or undefined slope, okay? Vertical slope. So for a horizontal slope, that means the line is just simply just going from left to right, okay? There's no rise, it's just all run, okay? So this horizontal slope is also known as your zero slope, because it does give me a run, but there's no rise whatsoever. So the slope is usually known as a zero slope, okay? So now for vertical, the undefined, that means I'm going to draw my line straight on through as best I can, okay? So a vertical slope or a vertical line, that's undefined, meaning I have more than one of the same x value that's being intersected on this line, okay? So when it's going like this, I can't have any x's whatsoever repeating, okay? But for the horizontal slope, I only have tons of x's, but the only thing that's repeating is my y value. So if I pick the point here, this will be 2, 4. Okay, so I have 2, 4. Here I have 7, 4. Over here I have -4, 4. Okay, the only thing that all these points have in common is 1, they're on the same line, and 2, their y values repeat. That's perfectly fine. But over here, I have 3, 3. I have 3, -4. I have 3, 9. Okay, here my x values are repeating. So we talked about this before, if it's a function or not a function. If not, take a look at our video when we did relations and functions, okay? So that was early on. And in order for something to be a function, the x values cannot repeat. So in this case, my slope for my vertical lines, my x's are repeating all day, all the way from positive infinity, all the way to negative infinity. So since they're repeating, this is going to be an undefined slope. So sometimes you'll see it like this, with a 0 with a line through it. That's called a null set. So if we're ever talking about sets of values, remember we talked about domain and range, and we did the sets, you can have this as a null set for your domain, okay? Because it's all repeating. All right, so for your slope of a positive, if I read it from left to right, my line is going upwards, meaning if I just draw a line from left to right, so here's my left, here's my right, okay, it's going upwards, okay, so that's a positive slope. So as your x values increase, your y values are also increasing, okay? But for you to have a negative slope, which is the next one, from left to right, it's going downwards. So that means as your x values increase, your y values are decreasing. So there's like a contradiction. So if I was ever able to look at a table of values, let's see if I can put my words together. As my x values increase, my y values also increase. So that's why it's going to be a positive slope. But if I look at my x values as they're increasing, but my y values are decreasing when I look at a negative slope, that's why you're going to get a negative slope. Okay? So hopefully you got that. So we got horizontal, zero slope. Vertical, undefined. Okay? Think about it. Do you want to be on top of a mountain and all of a sudden you just see a straight down, no curve, no ease into it like you're skiing or something? You just want to go, boom. Yeah, that's death. We don't want to do that. Okay? So slope, for it to be positive, it has a positive or slight increase. Okay? For negative, it has a decrease. Okay? So let's get with some examples. So it says, what is the slope of the line passing through ordered pairs 1, 5, and 6, 9? So we can do this one of two ways. We could do it graphically. Hey, I got a graph right here, might as well use it. So 1, 5, so here's 1, I'm going up 5, and I'm going to apply my point. 6, 9, so here's 6, going up to 9, I'm going to plot that point. And then I can basically draw my line as best as I can. Completely missed all the points. That's hilarious. So let's see. Let's see if I can go do it this way. Look at the idea. All right. So you got these 2 points. You got this point here and you got this point here. So now I can do that graphically. You can see my slope. Going from left to right, it's increasing, so that means it has to be a positive slope. But they want to know, what is the slope of the line? What exactly is that number? So graphically, we can count it as steps. So I can start from one point to another point. So I like to say that this is your house and you need to get to your friend's house. So you want to say, all right, you have to go up so many blocks and then over so many blocks. Because you can't walk through people's homes just to get to your friend's house. No, it's called invasion of privacy. That's not a good thing, okay? So if I count, I can start from this point and go up. 1, 2, 3, 4. So I went up 4, that's a positive 4. And then I went to the right, 1, 2, 3, 4, 5. That's a positive 5. So my slope is my rise over the run. So I rose up 4, but then I ran to the right. When I go to the right, it's positive. So my slope for this line is going to be 4 over 5. That's how we can find it graphically. Now, if I want to do it algebraically, I'm going to label some things. So since this is my first point, this is going to be my x1, this will be my y1. So the ones are representing, this is my x and y value of the first point that I see. So for the 6 and 9, this will be my x sub 2, and this will be my y sub 2. And the 2's are representing that, hey, these are the x and y coordinates for the second point. So now I'm going to use my formula. So we have y2 minus y1 over x2 minus x1. So all we're doing is substituting. What's substituting my y2? My y2 is going to be 9 minus my y1. In this case, my y1 is 5. The operation for your formula is always going to be minus. Only when you change it if you're minusing a negative. We're going to get to it, okay? So now we have my x2, which is 6, minus my x1, which is 1. So now you got 9 minus 5 gives me 4, and 6 minus 1 gives me 5. So I'm saying the slope is 4 over 5. Isn't that the same thing that we got over here when we did it graphically? Yes, it is. Now, when I try to teach this, for some reason, everybody struggles with slope. I can sit here and explain it as briefly to the point as possible. Everyone struggles with slope. I got people that can tell me the derivative of a cubic function. But they struggle with finding slope. But I'm just like, you use slope to get, oh, okay, whatever. Now, for me to do this, everyone knows they read from left to right, okay? So we're in England, we're in English, we're in America, we read from left to right, okay? Some people struggle with trying to figure out the y2 and the y1. They will tell me, okay, 9 minus 6, but the 6 is my x value. They always try to keep it in the parentheses. So what I like to do is, since we're so used to reading from left to right, I basically do this. I have my m is equal to, now, my y1 minus my y2 over my x1, x of 1 minus my x of 2, okay? Why not start with the y's and just go 5 minus 9, and then 1 minus 6, okay? Since you're so used to going from left to right, why not keep it in that flow? Now, you got 5 minus 9, that gives me a negative 4. And 1 minus 6, that gives me a negative 5. So we need to reduce or simplify that some more. What's a negative divided by a negative? Hopefully you're saying a positive, which gives me a positive 4/5. Guess what? You're gonna get the same answer. But here's the key. You have to make sure that your 1s are lined up vertically and your 2s are lined up vertically, as well as make sure your y's are in the numerator and your x's are in your denominator, okay? Because if you start switching things around, you're gonna get an answer. Oh yeah, it'll be wrong, but you'll get an answer, okay? So make sure that you have it all lined up correctly, okay? So let's try the next one. So we need to find the slope of these 2 points. So -2, 1 and -3, 3. So if we wanted to do it graphically, you got your -2 and +1, putting your point here. You have your -3 and +3, putting your point here. And then graphing your line as best you can. Jeez, man, I got to work on my line skills, because we're going to be doing a lot of graphing. All right, just looking at the flow of the points, looking at the line from left to right, what is that line doing? It's going down, so I should have a negative slope. So if I want to, I can start at this top point going down to the bottom point. So I'm going to go down 1, 2. So if I'm going down, that's a -2. And then I'm going to the right one, which is a +1. So my slope, which my rise in this case went into the negative direction, so we got a -2, over my run, which went into the positive direction, which is a 1. So -2 over 1 will be my slope. I'm kind of looking at this, and remember, fractions is nothing but another way of saying division. So couldn't my answer officially be a -2? Couldn't they're equivalent, right? -2 over 1 is equivalent to just -2, okay? So now let's do it algebraically. So I'm gonna do it both ways. So we have our y sub 2 minus our y sub 1 over our x sub 2 minus our x sub 1. So this is my first point, so that'll be my x1, my y1. This is my second point, so this will be my x sub 2, my y sub 2. So now let's plug in. My y sub 2 is 3 minus my y sub 1, which is 1, over my -3 minus a -2. So since every time you're going to be minusing a negative, put a parenthesis around it, please. Because what you're going to see eventually after you do a lot of these problems, you're going to say, oh, I have -3 minus, and it looks like a really long minus sign. And it's not. It's actually a minus sign with a negative. So when you minus a negative, it turns positive, all right? So this in my denominator is actually -3 plus 2. So then you have your 3 minus 1. So 3 minus 1 gives me 2. -3 plus 2 gives me a -1. So now we got 2 over -1. And you're probably like, yeah, but that's not the same as what we got. Remember, in order for a slope to be negative, one of the two, either the numerator or denominator, has to be negative. All right? So we actually still will get a -2 because what's 2 divided by -1? -2. So we still get the same answer of -2. If I wanted to switch it around and do my y1 minus my y2 over my x1 minus my x2, my y1 is 1 minus 3, and then you have -2 minus a -3. And we all know that when you have a negative minus a negative, that's going to turn positive. 1 minus 3 gives me -2. And -2 plus 3 gives me 1. So this looks similar to what we did up here, which still gives me -2. All right? So going straight to the practice, because I knew this was going to take a long time. All right? But we have -7, -3, and 2, -5. So if I graph it, here's -7, here's -3, and I'm plotting that point. Then we have 2, -5, and we're plotting that point. So just taking a look at this, just completely missed all that. Yeah, you get the idea. Looking at my slope, is it going to be positive or negative? It's going to be negative. So if I'm looking at it with my y sub 2 minus my y sub 1, my x sub 2 minus my x sub 1, remember, first point, this is my x1, this is my y1. Second point, this is my x2, this is my y sub 2. So all we're doing is plugging in. So you got -5 minus a -3 over 2 minus a -7. And you're probably saying, well, we didn't finish doing the graph one. I know. I'm trying to see if we can get it algebraically and prove it using graphically. Smart check. All right, so we have -5 plus 3, and we have 2 plus 9. So -5 plus 3 gives me -2. 2 plus 9 gives me 11. So let's see if I get the same thing if I do my y1 minus my y2, as everybody loves to claim it. They keep saying, forgetting the sub part. So my y1 is -3 minus -5. And then you have -7 minus 2. So when you minus a negative, they turn positive. So I got a +2. And -7 minus 2 gives me a -11. All right, even though the negative sign is now in the denominator, they're both representing the same negative slope. So if I wanted to graph, let me prove it, I'm going to start with this bottom point down here at 2, -5, and I'm going to go up to -7, -3. So I'm going to go up 1, 2, so that's a +2. And then I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right? But this time I went into the negative direction. Okay? If I go to the left, it's going to be a negative. If I go to the right, it's going to be positive. If I go up, it's going to be positive. And if I go down, it's going to be negative. So I still have my slope. And you're probably like, well, what happens if I started at the -7, -3, and I went to 2, -5, would I get the same answer? So if I do that, I would go down 1, 2. So this will be a -2 and go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't know what's going on. Oh, I know what I did. I gotta cut all this off. Guess what I did wrong? I gotta eliminate all of this. I kept saying it was 9, and it's really 11. I was like, it's only 9. I know it's going to be long. It's going to take forever, but I'd rather it be right than wrong. Okay. This is where we're going to start. Okay, so now we're going to go into the practice. So I know I'm spending a lot of time, so that's why I only wanted to do a little bit for examples and go right to the practice. So if you want to pause this and then push play to check to see if you got your answers right, okay? So as we're looking at this, we're looking at what is the slope of the line that passes through the ordered pairs -7, -3, and 2, -5. So graphically, I can go to -7, -3. So here's -7, and I'm going to go down 3 and plot my point. Then we have 2, -5. So here's 2, here's -5, and we're going to plot that point. And then I'm going to try as best as I can. I love how I draw lines and I put my head to the side like, all right. Oh, gosh, that's horrible. So, all right. So we can see that from left to right, it's going downward. So I should have a negative slope. So I'm not going to show the rise or run on the graph yet. I'm going to use the graph to see if what we do algebraically is correct. I know, she's smart, she's cute. We're gonna do this. All right, so we're going with m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So remember, if this is the first point that I see, this is gonna be my x sub 1 and my y sub 1. And since this is a second point, try to say that 5 times fast, that's gonna be my x2 and my y sub 2. So now let's put all that information into our formula. So we got y2, which is -5, minus my y1, which is a -3. So I'm going to put parentheses around it. My x2, which is 2, minus my x of 1, which is a -7. And I'm going to put parentheses around that. Because when you minus a negative, you're actually making them positive. So you have -5 plus 3, which gives me a -2. And the same thing's happening here. So 2 plus 7, this gives me my 9. All right? So it looks like the slope is a -2/9. Let's see if I do it the other way, if I get the same answer. So my y1, which is -3 minus a -5 over -7 minus 2. So when you minus a negative, it turns positive. So that 3, the negative in front of the 3, stays right where it is. You're not doing anything to that one. So the leading number, you don't do anything. It's just what happens after the operation and the other negative. So that means we have a +2, and then -7 minus 2 gives me a -9. So as I mentioned before, we got a negative slope. It doesn't matter if the numerator or the denominator carries the negative, as long as one of the two carries that negative. So if I do this, let me look at my graph. I'm going to take this lower point here, this 2, -5, and I'm going to take it over to the -7, -3. So if I do that, I had to go up 1, 2. So since I went up, it'll be a +2. and then over 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, since I went over 9 in the left, to the left, that means I'm going into the negative direction. So this is not going to be a positive 9, it's actually going to be a negative 9. So for me, my slope here, my rise, I went up 2, and my run, I went 9 steps in the negative direction. So you're probably saying, well, would I get the same slope if I started with -7, -3 to 2, -5? Well, let's see. So here in this case, I would have to go down 2, so that would be a -2. And then I would go over to the positive direction, 9. So this will be -2 over 9. And as I said before, as long as one of the numerator or the denominator is negative, it will still represent a negative slope. All right, so we did a lot. We got a lot of things done. So I don't know what just happened. Okay, I was like, what's happening? So if anything, try this one. I'm going to try not to talk too much in detail. We're just going to get right to it. All right, so find the slope of 4, 4, and 4, -7. So 4, 4, boom, boom. 4, -7, boom, boom. That means we have a straight line going straight through. So just looking at the graph, which is it? And let's go back. Not good at going back. Which one is it? Horizontal, vertical, positive, or negative? Hopefully you guys are saying vertical. Okay, so we should have an undefined slope, but let's see. Algebraically, we have our y2 minus our y1, x sub 2 minus x sub 1. First point, x1, y1. Second point, x sub 2, y sub 2. So that means you have -7 minus 4. Then you have 4 minus 4. So here you have a -11 is equal to 0. So can you divide? You're going to say, oh yeah, it's 0. Go ahead. Try to put it in any calculator. So that means if I did the reverse, 0 times 0 will give me -11. So here's my thing. No O below. If you do it algebraically and you get a 0 in your denominator, you will always get an undefined, a null set. You will always get that. You cannot take a number and divide it by 0. You can take 0 divided by a number, but not a number divided by 0 to give you an answer. Okay? So this is going to be an undefined. I can do it the other way, and guess what? I'm still going to get 4 minus 4 as my denominator. So if your x values repeat, you will always have an undefined slope. All right? So I can find the slope of the line algebraically and graphically. Yes, use your formula. Use your graphs. Plot your points. So you have your horizontal, which is 0 slope, your vertical, which is undefined, you have your positive, and then you have your negative. All right? So we took care of the previous exit ticket, the guiding notes, the practice. Now we're going to work on this exit ticket for this particular lesson. So you have 2 questions, all right? So each of them, I want you to find the slope of the line, but take a look and make sure you pay attention to what the points are, okay? So we have 3, 2, and 8, and 6, and I want you to do both of these algebraically, okay? So if you want to start with a graph just to check your answer, you can, but I just want them algebraically, okay? And for the second one, it's 9, -6, and -7, -8. All right, so we worked on slope. I love doing slope. It's so much fun. And then you're probably like, where'd she go? There was a window. Okay, but just so you know, everything is going pretty well. A lot of you guys are giving me great feedback, which is great. But if you have questions, if you have concerns, if you're just like, hey, when are we going to get into, I don't know, point slope formula? Don't worry, it's coming. Or, hey, how do I graph, blah, 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 blah. Please comment below. Like, subscribe, share, and don't forget to comment. So like always, this has been a joy, and hopefully you guys are learning more from this. And stay tuned for more videos. Take care of yourselves.